Hello. Hi, everybody. My name is Raffaele Spazzoli. I am an architect for the OpenShift consulting practice. And this is Andrew Buck. Do you want to introduce
How's
yourself?
everyone doing this morning? Andrew Block, I'm a principal consultant at Red Hat, primarily focusing on OpenShifts and containers, but also a little flavor and integration here and there, but primarily OpenShift these days.
And today we're going to talk about container-driven continuous delivery. So we're going to talk about how we do continuous delivery with containers, and especially inside of OpenShift. Our agenda is we're going to talk about a little bit of immutable infrastructure. There is a slide and some thought that I would like to share there. And then we're going to share how we do continuous delivery in OpenShift, what is our model, and then some best practices that we have gathered over the course of the last year.
So what I'm going to do now is a show of hands. How many of you are currently using OpenShift today? How many of you have never heard of OpenShift until you came to Red Hat Summit? Okay, that's fair. Good. Just kind of get a level set of who's here today.
Cool. Okay, so in this slide, I'm trying to capture the concept of immutable infrastructure with a slightly different perspective that you may have found in articles and blog posts. And there is this idea of progressive locking down the infrastructure before we even start to deploy, so that when we go to deploy, we know exactly what we're going to deploy. So the first thing that we lock down is the business logic when we compile our code and we build our artifacts. We always done that. There's nothing new here. Then we lock down the binary execution environment by creating an image. This could be a Docker image, as in this example, but it also applies to VMs. So the concept is we create the binary execution environment, and then we store it somewhere, and then it becomes immutable. And finally, we lock down the topology that we're going to use when we deploy our application. And by the topology, I mean our application usually has more than one component, right? And then this component will talk to each other, and we'll need storage, and we'll need services. We will expose routes if we are in OpenShift. So we lock down everything, all of this stuff. In the case of OpenShift, we do it with our OpenShift API objects, right? So our manifest, the YAML files that most of you probably know. And until this point, we haven't even deployed anything. We have just simply created a contract. If you think about it, it's a contract between our application and the infrastructure that is required to run it. Okay? It's a machine-readable contract. So it's going to be very easy to automate creating that infrastructure and having the application run there. And if you think about a Docker image, it's really, in most cases, it's just a bill of materials of what you need, right? Install this package, configure this file, install this package. Same thing for the OpenShift API object. I need this image running, I need this container, I need this service, I need this route. So it's the bill of materials of what we need from the infrastructure to run our application. So we have locked down almost everything. There is only one thing that has not been locked down, which is the configurations, right? Properties, environment configurations, maybe credentials that our application need to work in a specific environment. So the last step is we deploy in an environment, we inject the configuration, and our application is up and running. Okay, so we are doing this with containers. It works the same with VM. The concept for me is we are building a way, for the first time, I think, we are creating a way to define a contract between the application and the infrastructure. And it's, like I said, machine readable, so easy to automate. And now we are going to see how we are going to automate it inside of OpenShift.
So
go ahead.
So typically, when we work with a lot of customers, we want to define a software development lifecycle for both our development and then eventually for our deployment. And what we see with most of our customers are the ability to create two separate clusters of OpenShift. One that manages your non-production applications and one that manages your production applications. There are various numbers of reasons why you want to create those two separate environments, whether it be security, whether it be performance, or just policy of the organization. Each one has their own certain constraints. So for the entire software development lifecycle, it all begins with the developer. You have the developer create their application. They're going to go ahead and package it up, and typically using a CI tool such as Jenkins. You can use any other tool that happens to be out in the market today, but Jenkins seems to be the one that, you could use the one that comes with OpenShift. We have integrated pipeline support with an OpenShift, or you can use an external Jenkins server that you and your organization may have been using for the last X number of years. You're going to go ahead and create your binary, as Raphael mentioned previously, and then you're going to want to create that Docker image. That Docker image is going to be taking into account both your application and any other components that's going to constitute that underlying image. You're going to go ahead and produce that initial image and put it to a dev environment. Now, in our non-production environment, we're going to separate our environments into different projects. Who here is familiar with the concept of OpenShift projects? Basically a way that you can create your own separate workspace using OpenShift's role-based access controls to ensure that only certain users have access to that project. In a development environment, you're typically going to not be too concerned about who has access to a development environment, but as you go higher up in the stack, you're going to want to lock that down so that only certain users have access to perform certain functions against that project. So especially as you get closer to production, you're going to want to consider who has access and then what are the steps that you're going to take to get it to production. And then what we're going to talk about here is once you have the image in the development environment, how do you get it to higher level environments where you're going to want to promote it? And some organizations use Jenkins, some other organizations use some other tool to manage the promotion and approval process. There are a number of different tools out there that handles that, but for simplicity's sake, let's just use Jenkins. There's a number of ways in Jenkins, different plugins that you can integrate into Jenkins that you can orchestrate the entire process. And at time for promotion, you're going to go ahead and promote between each individual project in the non-production environment. And when it's time to eventually get yourself to production, you're going to cross that boundary between the two clusters and promote between the two environments. And we're going to talk about the different ways that you can promote between different projects.
And one thing I want to add, we call this the MVP pipeline, so minimum viable product, because your pipeline is going to have much more. But today here we focus on the mechanics. All right, so moving stuff around from one environment to another. Your pipeline will also have validation steps. Right. That's completely up to you which one they are. You can do unit test, integration test, code scanning, image scanning, and everything that you can imagine to validate your code. But here we're really talking about how we do this, moving of images and configurations across the various environments. And the other thing to remember, this is a model, okay? This works with any tool that you want to bring to the table. We usually instantiate these models with Jenkins in our demos, but it doesn't have to be Jenkins. You can have your orchestrator for the pipeline. So we have tried to think about over the last year about what are the things that you really need to do in order to instantiate this model, regardless of the tools that you're going to use. Okay. So usually, before we start designing the pipeline with my customer, our customer, we try to focus on a few considerations. And yes, I said design the pipeline because I try to really do a design like if we were doing a design of a piece of software component. We also want to design the pipeline and then we want to implement. So from an organizational perspective, I invite our customers to think about who is going to be the owner. We see a movement to, sometimes it's called a movement to the left and a shift to the left. So the owners, sometimes the answer is that the owners are the developers. Okay, we have seen in a few presentations that now we have this Jenkins file. If we think about Jenkins, that is, in our Git repo with our code. So in that case, the owners are the developers. The owners can the developers can change the pipeline, can add, remove steps at their own will, right? But some organizations like the separation of duty, the concept of separation of duty. So they want developers to write code, and then the release management teams to write maybe the pipeline or the rules around the SDLC. So this is very important. You have to decide who's going to own the pipeline, and and what are the rules in general around your pipeline. If you want to have standards, or if you're allowing complete freedom for your project.
And the great part about this is when we talk about organizational technical, it really emphasizes this entire DevOps model, bringing these two previously siloed areas together and working together to create this consistent process for how you're going to go ahead and deploy and deliver applications to production.
The second question is, what type of automation do you want to build around moving code and moving your application? And there are two models in my mind. One is point and click, the other one is the true concept of pipeline. The point and click model is, I think, what most enterprises that haven't started this journey are on, which is I decide the version of the code I want to release. I have some UI somewhere where I decide the version of the code that I want to release. I select the environment and I click a button, and some automation deploys the code there. The pipeline concept is a different thing. The concept is something happen in the source code. Maybe there is a pull request or an event. I start a build, and then I can never use anything else. For that instantiates the pipeline. And the only thing that can happen is I go forward with this pipeline, and whatever is the code that was built gets promoted in various environments, or I can abort. I can never get to choose which code to deploy where. The pipeline knows about it. Okay, so the pipeline can get to the end, which is production, or it can abort. But you cannot say, okay, I wanted this version here in this environment. That version will get to that environment only if all the steps of the pipeline are okay. So those are two different models. It's still full automation. In both cases, you get full automation about your deployments, but you have to choose the model. Okay. So we have gathered a few best practices, or in general practices, that will help you create these pipelines. In here, we are assuming that you are deploying in OpenShift. Things tend to get way more complicated if you have to do a mixed deployment, right? Your application is complex. You were able to onboard only part of it in OpenShift. So something gets deployed in OpenShift and something is outside. That's a little bit out of scope, and it's always a case that we have to analyze together. So let's start with, the topics that we're going to cover are how we move images, how we move the API objects, okay? How we promote them across the environment, and then how we manage the environment-dependent properties, okay? And how we manage secrets, and finally how we execute a release, okay? So how we do a deploy.
These are all very important steps that every organization that we both have run into has struggled with initially, because they have to think about how are we doing it today and how do we want to do it tomorrow, because how they're doing it today typically isn't how they want to do it in the future. So we spend a lot of time making sure they take in all the different options in their organization, and then we try to put together a consistent model that they'll be successful moving forward.
So we have here a couple of tools that we can use to do image promotion.
So typically we emphasize the use of two tools to promote between either multiple projects in OpenShift, or typically multiple clusters of OpenShift. So you want to go from a non-production environment to a production environment. We're going to use two different tools to actually facilitate that process. The one is the easiest and most common is you're going to use Docker. Docker out of the box, you can just use the Docker command line tool, do a Docker pull down the image, and push it to the next cluster. Another tool we started to leverage is one from the Project Atomic team called Scopio, which doesn't require Docker to be installed on the machine at all. So you can run it in a Jenkins slave or some other process outside or inside of OpenShift. Doesn't need to have any tooling except for this binary CLI tool, and it's going to communicate to Docker using its RESTful API, pull down the image layers, and then push it to the other registry. So it's very lightweight, and we've seen a lot of customers use this tool because they are really concerned about having to manage Docker and set it in general. So this has been very popular moving forward, and actually we've seen a lot of uptick, and the Project Atomic team continues to add more and more functionality to this project. So we're going to see it continue to adopt in more and more customers.
And this slide is intended to explain this concept a little bit deeper. So when you use a Docker engine to do a pull and then a push, right? The model is I pull the image locally and then I push it to another registry. So if you're wondering why do I have to do that, it's because sometimes you have to cross clusters, right? So you have to move from the registry that is used in one cluster to the registry that is used in the next cluster. So if you do that, your Docker client is communicating with the Docker server, your Docker engine, to do the pull. Then it puts the files in the local storage, and then you do a push, and you push it to the registry where you want to go. So assuming you have the right permissions, you can do this operation. But every time you have access to a Docker engine, you are basically root on that VM or that machine where the Docker engine is running. So this has been a security concern for our customers for a while. So much so that Andy and I were thinking, this doesn't make sense. We just want to move bytes. Why do we need to be root? And we started a project that we called Image Hauler that was supposed to move images. And then shortly after, we discovered this package from the Atomic release where this just talks to the registry API. And it's just moving images, so moving bits. So if you have the right grants, you can do this move, and it's also very optimized because you know that images are organized in layers. Before starting pulling the layers, it checks if the layers exist already in the destination registry, and therefore it doesn't pull the layers that are not necessary. So it's going to be even faster. Some of our customers. So this is in the RHEL extra package, repo, sorry. And it's unclear. Some of our customers are still wondering what is the support level for this tool, but it's supported. It's part of the RHEL release, so you can start using it, and it's going to make your life simpler.
Another thing I want to point out is this model assumes that you are using OpenShift integrated registry as your source of truth in the cluster. A lot of our customers use an external Docker registry like Artifactory or Nexus. This model assumes that you are using OpenShift's integrated registry for the storage of your images in both clusters. So I just want to keep that out there, is that you may be wondering, well, I already have an external source, what do I have to pull and push? Now, if your clusters can talk to that external registry, great. But this is just explaining the process if you have to cross the clusters using just the internal Docker registry within each OpenShift cluster. Did I have a question? Okay, perfect. Thanks. We have a question back here?
Let's go back to this. Oh,
Nope.
sorry. It's going in the wrong direction.
Just wondering, why you guys have multiple registries for multiple environments instead of you push to one registry and that's the same registry that dev and prod pull from.
So did everyone hear the question? Okay. So the question really was along the lines of, and that kind of goes into what I was saying, if you have an external registry that is able to be used by both environments, you can continue to use that. You won't have to worry about the cross-promotion process. But if you are using either a registry that may not have access in both clusters, because I have a lot of customers who have very strong security concerns, where you have to still do that promotion process, this is where that comes in. Or you are using OpenShift's internal Docker registry, that's the other alternative use case that you want to emphasize in this model. Okay.
Okay. So in this use case here, if we were using the internal registry that is in each of the cluster, then to move the bits from one to another, that's the way we recommend doing it.
Yes.
When moving the image between two when moving an image between two OpenShift environments, so you have to move it from one internal registry to the other. Permissions.
So remember, when it comes to the registry, it still has the full role-based access control. So whatever tooling that you're using has to have permission to push it to the registry in OpenShift.
Exactly. So you have to have access both to previous.
Right. You would have to have access
permissions to both.
Correct. And you want to make that promotion facilitator with higher permissions is going to be able to manage that.
Yeah. So this operation is going to be done by your orchestrator, which will need to have those credentials. Oh, yeah,
it would be the exact, because in the end, it's still, so the question, the gentleman had never used Scopio previously, so the idea is you're still authenticating to a Docker registry. Whatever tool you're using is very agnostic. Because either you're going to do a Docker login using the Docker native command, or just use the credentials in Scopio.
Right. Then I want to talk about how we move OpenShift API objects. Again, if these are environments, we need to create API objects in these environments. And so you understand what they are, right? Services, deployment config, secrets, config maps, anything that you define in OpenShift as a manifest. And you may need to update these objects, right, during a release. For example, you may be adding a container to your pod, or you may be adding a new component to your application, or you may be changing the size of a container, adding more memory or more CPU. Or, right. Or the most common thing is, sorry, do you want to say it louder?
No, just repeat the question. What was the question?
You say you may want to use a different source for your registry. Or you may want to, what happens almost most of the time, you want to use a different tag for the image you are deploying, right? So we have come up with this strategy to update the OpenShift API objects. The first thing you need to do is to templatize them. So you create a template of what is that you want to deploy with this pipeline, okay? And then you process the template with this command, so that turns the template into an array of objects that can be requested to OpenShift. So you actualize them, you make them instantiate them for the environment where you want to go, right? You may have some parameters that are dependent on the environment. And then you do this command that ocapply, which it calculates the difference between what is already deployed and what you are asking to deploy, and then essentially does a patch.
It does a strategic merge in reality. So it basically tries to take what you have, what you want to apply, and try to find the best match to the resulting objects.
And this is important because if you were to delete the objects and recreate with the new ones that you want to deploy, you would have an outage, right? You would essentially delete your pods and then start a deploy from scratch. In this way, instead, you just update the objects, and then you can ask for a rolling deployment or for an update of your application without taking an outage. Okay? So this is our recommended approach right now. Something you want to add? Yeah. For environment-dependent properties, we don't have a recommended approach. We have 4 approaches because that's really dependent on your application. Okay, and the first approach is use environment variables. You can pass environment variables to your pods, and so you can change the value of the environment variables by updating the OpenShift API objects, so the thing we have seen just before. And that would work, right? So your application needs to use those environment variables. But this approach doesn't scale very well when you have, more than 3-4 environment variables.
How many of you have 30 or 40 configuration files? If you are a Java developer, how many Java developers here? Or at least work in the Java space? Java applications? you get a lot of variables very
Yeah.
quickly. So as Raphael said, it becomes very difficult to manage as your template becomes massive with each environment variable that you have to deploy and configure into your different templates.
So the next approach is to put all the values, all your properties in different files for all the environments that you are going to deploy to, and then pass only one single environment variable that says in which environment you are going to deploy. And then your application uses that information to pick the right file to read and to initialize itself. And this, if you're using Spring, you can brilliantly solve this just using Spring profiles. And Spring this feature of Spring will just make this happen for you. If you don't use Spring, you have to do a little bit of coding in which you select the right file to read. But again, this doesn't work very well if you have ephemeral environments. So if you don't know in advance what your environments will be in the pipeline, then you cannot create the right files.
So the next one we're going to talk about is config maps. Now, OpenShift has had the option to store values on the platform since the beginning 3.0, but they were called secrets. But what they introduced in 3.1 and 3.2 is this concept of config maps, which really emphasize property files. Secrets are automatically encoded and primarily used for binary objects. These are great for key value pairs and just text files. So the way that you can basically take a key value pair that you typically see in any Java or any real application and inject it into the platform very easily and update if you need to on the fly. That's one of the key parts about config maps is it is able to automatically inject the updated values in real time. So as long as your application is configured to be able to reread that configuration file, you don't need to have any downtime of the application. You don't have to delete a pod, you don't have to roll the application. It can then go ahead and start using those updated property files immediately.
Yeah, so config map works very well. If you're not correctly managing your API objects, doing what we said before, that's an additional object to manage, and so sometimes that is seen as a problem. So if this doesn't work for you, or if you need to update your environment variables with a high frequency, then you can use a config store. Config store is simply a service available to your applications that serves configurations. Okay. So you can easily create it, or you can use, there is a Spring implementation of this. The only problem to keep in mind is if the config store is not up and running, your application may not be able to start. Right? Okay, so now the config store becomes a piece that has to be very, very available in your
It's another failure point. So you really it's a give and take model of, do you want to manage complexity or do you want to manage additional potential failures of your application? As with everything we're going to talk about today, it's all give and take. What can your organization really take on, and what kind of risks that you want to take on with the organization?
Did you have a question? Oh, that's it.
If I update the config map, will it automatically remount it into the pod?
Can you say it one more time?
If I update the config map with a new property, will it remount it into the pod?
Yes, it will automatically update the value of the config map in the running application.
In the running map.
Yes, that's one of the key differences between secrets and config maps is it will update real time.
Yeah. So next topic is credential management. Credentials are similar to proper environment-dependent properties, but they have the additional requirement that they need to remain secret or visible only on a need-to-know basis. So OpenShift gives you secrets to solve this problem, and if you can use secrets, that is the recommended approach. But secrets have some limitation with regards to security. For example, your cluster administrator can see the secrets. Okay, it can see all the objects in OpenShift, including the secrets. Or once the secrets are mounted, a node administrator can see the mounted file systems, therefore can see the secrets. So if you need something more, you want to consider integrating with a secret store. This is a type of software that now it's becoming, it's becoming common, and there are many instances of this secret store. I just mentioned here a couple of them: CyberArk, which I think is here, and HashiCorp Vault.
There's a lot of talk in the Kubernetes and OpenShift communities around secrets and integrating these third-party tools into the platform. So there's going to be a continued discussion and evolution around this space moving forward. So we're really excited. Rafael and I have been working on solutions with not only our customers but also internally, and we've already seen additional tools and interest around the secret store in the last few months. So expect to see even more in upcoming releases of the product.
Are you guys planning to make the secrets RBAC more granular, so that like a cluster admin cannot, because it's very convenient compared to putting CyberArk.
So there are some changes coming to secrets. I believe it's either going to be in, there were some changes in this last release, I believe, but I know there is some changes in the next few releases on the roadmap that's going to talk about how to manage secrets a little differently. So it is on the roadmap, so you will see some changes soon.
Right.
So I want to talk about how we deploy new versions of our applications. So there are three primary methods for rolling out new versions of an application in OpenShift. One is a recreate model, the second is a rolling deployment, and third is a custom deployment. The first two are about 95% of the use cases that you're going to see. If you want to use number three really is an edge case of number one and number two doesn't work for me or my organization. I want to have full control of how we release software. So OpenShift does provide the ability to basically customize the entire rollout of an application to production. So let's talk about the first one, recreate. What a recreate will do is, let's say you have an application currently running, it's running great, you want to update something, you want to add a new feature to the application, you want to deploy it to the environment. What it's going to do is it's going to take the existing application and scale it down, and then bring the new application version and scale that up. So the key here is you're going to have an outage, which is good and bad, depends on where you're using this strategy. You want to use this strategy, I use this strategy all the time in development. It doesn't matter if I have an outage, I'm just developing. Or, let's say you have an application that really has no SLA. It runs between midnight and 6 a.m., an overnight process. You're going to update it at 2 in the afternoon. No problem, there's an outage, it's not being, no one's actually using it. But what we see most people use as a rolling deployment, where you're guaranteed to have no downtime whatsoever, because what you're doing is you are not scaling down your application at all until your new version comes up. You're going to have your existing application running, and then you're going to have another one that comes up. And through the use of different health lifecycle hooks within OpenShift, you're able to programmatically determine when that application is healthy. So there's a concept of liveliness checks and readiness checks in OpenShift. A readiness check is a check to determine what dictates your application being healthy. Can I hit port 8080 on an endpoint? Can I hit an health endpoint? A common endpoint in most applications these days is to provide some sort of health endpoint that does either just a okay, or it's going to do some more complex mechanisms. It's going to check to make sure its application is okay, and maybe it's even going to go ahead and validate that it can talk to a back-end database. You can make it as complex or as simple as you want it to be. Only when that check passes will it determine, okay, that new version is running, I can go ahead and scale down the old application. There is no downtime because both applications are still running, but no traffic is actually hitting the new application until that health readiness check passes. And then you can combine the rolling deployment with a different sets of routing policies. So you can have multiple versions of an application running at the same time. A blue-green deployment is you're going to take the first application, they're going to spin both of them up. You're going to spin both the old application and the new application up at the same time, but all your traffic is going to be routing to the old application. When you feel the need to then promote or switch over the traffic, you're going to change the routing policies to take all the traffic from the old application and route it to the new application. The key here is that your old application is still running. There's just no traffic going to it. So let's say some testing occurs and you see some problems with the new application, the new version. You can immediately go back to the old application without any, without any concern. You don't have to go ahead and spin up new servers, new hardware. Your application is still running. You just flip the router over, and then you can quickly, remedy any issues that may have occurred. The other routing mechanism is what we call A/B routing, where some traffic hits the old application and some traffic hits the new application. So you can go out and roll out new features to a subset of users versus, let's say I wanted to add a new button to my website. I think it looks cool, but let's say the community may not think it's a good idea. You can go ahead and get some user feedback on the new version of the application, along with not breaking into the old version of the application. So OpenShift has policies where you can specify, okay, I want 30% of my traffic to go to the new version and 80% to go to the old version. And you can go ahead and change that on the fly.
So we have some references on blog posts and articles that we have written around these topics. And I think we have a slide where you can, if you want to get this presentation, this one, you can scan this code. And now I would like to open it for questions.
Any questions from anyone? It could be about anything. The deployment? Or the pipeline? The pipeline inside or outside of OpenShift. It really comes down to your organization. I have organizations who want to put everything in OpenShift, everything, and have nothing outside of OpenShift. Or I have some organizations that want to continue to use their existing CI process, but integrate into OpenShift. And that's really at the organizational level of where you really want to jump in. Because if you have a lot of applications that are running outside of OpenShift and you want to continue to use that same tooling, the good news is you can communicate with OpenShift the same way, whether it's running with an OpenShift or without it outside of OpenShift. It's all API based. And there are plugins that integrate with that API. Anyone else? Well, Raphael and I are going to be around, so if you want to come up and ask us some questions, we're going to be around. And I want to thank you all for your time this morning.
Thank you very much.